Hi, this is a practice quiz solutions for the quiz that you have tomorrow on Thursday, February 6th. Anyway, for number 1, change that first problem to x squared plus x minus 20. It'll still be able to be factored, but then we'll actually be able to reduce it. So there was an original typo. So if we're going to simplify these two polynomials, first we need to factor them each. X squared plus x minus 20, put in the x's. Two numbers that multiply to be negative 20 and to be positive 1, be 5 and negative 4. In the denominator, factor that. X and x, two numbers that multiply to be negative 15 and to be positive 2, be x plus 5 and x minus 3. Alright, since they have a common binomial, x plus 5, I can divide x plus 5 by x plus 5, and this will factor down and simplify to x plus 4 over x minus 4 divided by x minus 3. So that's how number 1 works. Number 2 is basically the same thing. Factor the numerator. 5x squared plus 10x. I can factor out a 5x from each of those. In the parentheses, 5x squared divided by 5x is x. 10x divided by 5x is 2. So the numerator factors into 5x times x plus 2. In the denominator, factoring my favorite trinomial, x squared plus 5x plus 6. Two numbers multiply to be 6 and to be 5. Of course, are 2 and 3. So x plus 2 times x plus 3. Now, in the numerator and denominator, there are common binomials of x plus 2, so they cancel. What's left is the 5x over x plus 3. All right, so that's number 2. Number 3, x squared times 5 over, 3x squared over x plus 7 times 5 over x. We're just multiplying, so we can multiply straight across. 3 times 5 is 15 with the x squared. In the denominator, x plus 7 times x. I like to put the monomials out front. So x times x plus 7. Out of each of those, the only two things that'll cancel is I have an x in the denominator and x squared in the numerator. I can factor out the x in the denominator with one of the x's in the numerator, leaving just an x in the numerator. So I have 15x over x plus 7. All right. Now, number 4. All right, this looks like a doozy, but it's not that big a deal. Basically the same thing. Factor all the trinomials into binomials. Remember, when we're dividing two fractions, we change the dividing to multiplying, and we flip over the second fraction. So I'm going to do all of that in one step. Factoring the numerator here, that x squared plus 7x plus 12. Put the x's in, then two numbers that multiply to be 12 and to be 7 are 3 and 4. So that factors into x plus 3 times x plus 4. In the denominator, I'm still going to have an x plus 5. See how I add the parentheses? It makes it remind you that the x plus 5 represents one number altogether. Now, I'm dividing by 5x plus 15. It's going to go on the denominator because I'm changing it from division to multiplying. And this flips. So when I factor 5x plus 15, I can take 5 out of each of those. Divide 5x by 5 of x. 15 divided by 5 is 3. So I end up with 5 times x plus 3. Now the last thing to factor is x squared minus 25. That's the difference, two perfect squares. So x and square root of 25 is 5. So x plus 5 times x minus 5. Okay, since I'm multiplying, I can cancel across the fractions. I have an x plus 3 and x plus 3, x plus 5 and x plus 5. All right, nothing else cancels, so in the numerator I've left x plus 4 times x minus 5. In the denominator, all I've left is 5. And for these problems, we're just going to leave them in the factored form like that, if you don't mind. Okay. Now, let's keep going. Let's get number 5 done before I start a new video. Number 5. I'm just adding these two fractions together. Just like anytime you add fractions, you need a common denominator. So, if you think of x minus 8 as a number and x plus 2 as a separate number, common denominator, I'm going to end up having to multiply the two numbers together. So x minus 8 times x plus 2. X minus 8 times x plus 2. That will be the common denominator. Now, for the first fraction, 6 over x minus 8, I'm missing the x plus 2, so I'm going to have to multiply the numerator and denominator by x plus 2. In the second fraction, I have an x plus 2 in the denominator, but I need an x minus 8, so I'm going to have to multiply the numerator and denominator by x minus 8. All right, got kind of messy there, but for the new fractions, I'm going to go ahead and distribute the 6 times x plus 2, so 6x plus 6 times 2 is 12. Over here, 2 times x is 2x, 2 times negative 8 is negative 16. All right, so I have my two fractions with common denominators. The next step is to put them all over one denominator. And the last step will be to simplify. 6x plus 2x is 8x. 2 plus negative 16 is negative 4. All right, we always like to factor everything just in case something will cancel. So I'm going to go ahead and 8x plus minus 4. I can factor 4 out of each of those. And I'll have 4 times 2x minus 1. And then the denominator, x minus 8 times x plus 2. Well, nothing's going to cancel, so this is our final answer for number 5. All right, I'm going to make a second video for 6 through 9. Okay, talk to you later. Bye.